Okay, this is for response question number 3 from the mock exam. So this is pretty much all you were given with a picture. And for part A, you're supposed to find the average rate of change. So normally the way we would find, well, okay, so just not to be confused, this formula will give us an average value. Okay, this is asking for an average rate of change. So the rate of change is just the slope. So we're being asked for the average slope. So how are we going to do that? Well, we're going to take, so your picture currently looks like this, something like that. So if we need the average rate of change from x equals -5 to x equals 5, what we're going to do is find, let me get out the color, the slope of this line right here. Okay, and then we know that, one of these slopes would actually be the real average, but for right now that's all we got, is that pink line. Okay, so that's what we're dealing with. So let me get back my other color. Okay, so we have from x equals -5 to 5. Okay, so how do we find the slope? So I know you're going to think this is babyish, but I'm doing it on purpose. Okay, so I know that these values here represent my x's, right? Because I have 2 points. I have a -5 something, and then I have a 5 something. So, whoops, not a 0. Taking that out. Okay, so x1, y1. So, God, I don't know what's wrong with me. Okay, x1, x2. Okay, so I know that I could at least do 5 minus a -5. Okay, but what about my y's? I don't know what my y's are. So to get my y's, I'm going to have to do g of -5, and I'll do g of 5, and that will get me my y values. Okay, so that is our plan, that we need to figure out those 2 points. Okay, so now we have a plan. Let me erase this and make some room. Okay, so we currently have -5 something, and we have 5 something. So what happens when x is equal to -5 or 5? It doesn't matter which one you do first. I'm going to do 5 first because I just know it's going to be easier. So if I want g of 5, that means wherever I see an x, I'm going to put 5. Okay, so this would be the area under the curve going from 1 to 5 of f of t. Well, the graph that they gave you is f of t. So look at that picture going from 1 to 5. And you have a picture that looks something like this. If you close it off, you will end up with a trapezoid. Right, this is a base, this is a base, and this is your height. Okay, so we're going to do 1/2 base 1 plus base 2 times the height. Okay, so base 1, we'll use the top one, and all you have to do is look at the picture, and it's equal to 2 units. And then we'll look at the bottom base, and all you have to do is look at the picture, and there are 4 units. And then we need our height, and you just look at the picture, and it is 4. So 1/2 of 4 is 2, 2 plus 4 is 6, and 2 times 6 is 12. So when x is 5, y is 12. Okay? Now we're going to do g of -5. Okay, so that would be the integral going from 1 to -5, because we're replacing the -5 into the x of f of t dt. But we can have the bigger number on the bottom, so we're going to flip them and put the smaller number on the bottom. But when we do that, we have to add a negative sign, and we have f of t dt. Okay, so here's our negative, and now we need to find the area that's going from -5 to +1. Okay, so I'm just going to go to another screen, and then I'll just keep going back and forth. So this is what our picture looks like. Something like that, and then we have a quarter circle here, and then we go like this, and we go like that. Okay, so these are our pieces basically. Okay, I'm just going to get another color. Okay, so we're going from -5 to 1. So -5 is going to start here, and 1 is going to end here. Okay, so we need those two areas. Okay, so why don't we start first with this triangle over here. Okay, so this triangle over here is going to be 1/2 base times height. Sorry, I'm just double checking to make sure that I have the right numbers. From -5 to 1, yep. Okay, so this is 1/2 base times height, so that's going to be 1/2. This is our base over here, so just look at the picture and you'll see it is 1, 2, 3 units. And our height is this, and that is 4 units. So we have 1/2 of 12, so 1/2 of 12 is equal to 6. But where is the 6 located? It's down here below the axes, so that's really going to be a -6. Okay, so far we have a -6. I'm going to put it down here. All right, now let's erase this. I'll get another color. Okay, so now we need the area from here to here, because this is exactly 1/4 of a circle. So it's going to be pi r squared, because it's the area of a circle, but divided by 4, because it's just 1/4. Okay, so we have pi, and the radius is going to go from here to here, or from here to here, it doesn't matter, but if you look at your picture, that's equal to 2. So pi r squared over 4. So you get 4 pi over 4, those cancel, and you're just left with pi. But that is also under the axes, so we get a negative. So we have a negative pi as part of our area. And now I'm going to get one more color. I'm going to erase this. And now we need the area that is right here, this little triangle. So it's going to be 1/2 base times height. This is our base, so you're going to look at the picture, and that's equal to 1 unit. And then our height is this piece here, and that's 2 units. So you're going to get 1/2 of 2, which is equal to 1, but again, it's below the axes, so this is negative. So we're going to have a -1. Okay, so our area going from -5 to 1, so the area from -5 to 1 of f of t dt is going to be -6, negative pi, -1. So if we combine that, we end up getting a -7 minus pi. Okay, so I'm going to go back to the other screen. -7 minus pi. -7 minus pi. Okay, so we're going to distribute this negative that's on the outside, and we're going to get a +7 plus pi. Okay, so just going to go back and change my color. Okay, so that is going to go here, 7 plus pi, right? Because that's what happens when x is -5 in G. Okay, so the whole goal of this was to be able to use the slope formula, and now I have 2 complete points. Let me change colors. So this is my x1, y1, x2, y2. So I'm going to plug into slope formula. So y2 minus y1, so I need my parentheses, over x2 minus a minus x1. So I'm going to distribute 12 minus 7 minus pi over 10. 12 minus 7 is 3, so we get 3. Sorry, 12 minus 7 is not 3. 12 minus 7 is 5. 5 minus pi over 10. And that was the final answer, and the point values were, if you just wrote g of 5 minus g of -5 over 5 minus a -5, that was equal to 1 point. and then this final answer, that was worth 2 points. So part A was worth 3 points. It was kind of time consuming, that one. All right, let's move on to part B. Okay, so part B is asking for the instantaneous rate of change. It just means find the derivative of g. So we're looking for g prime when x equals 3. So we want g prime of 3. So before we could find g prime of 3, we need to find g prime of x, which we do not have. But we do have g of x, and g of x equals this. So if I want g prime, I'll add a prime. But what I do to one side, I need to do to the other side. So instead of writing it as prime, I'm going to write d over dx. It all means derivative. Now, oops, just dropped my whole iPad. And now you can see that this is the second fundamental theorem of calculus, which says just take this top limit, put it into the function. So g prime of x is equal to f of x. Okay, so I'm just going to go over here. So we're looking for g prime of 3. So g prime of 3 equals f of 3. Well, you have the picture of f, so just look at when x is 3, what is y, and you will see that it equals 4. And that question, the answer was worth 1 point. So that was kind of cheap, that 1 point. Okay, let's go to C. Okay, part C is asking, when is G concave up? So we know that when G prime is positive or greater than 0, G will be concave up. I'm just going to abbreviate, okay? So we need to find G prime, G double prime, I mean. All right, now we found previously in B that G prime of x equals f of x. So if I add a prime to both sides, that means G double prime equals f of x. Okay, so we wanted to know when is G double prime greater than 0. So I'm just going to rewrite that so you can see how I do the substitution. But G double prime is equal to f of x. So I'm going to take out my G prime. I'm going to put, whoop, this is a prime, f prime of x. So the real question is, when is f prime greater than 0? So, in other words, when does f have a positive slope? Okay, well, wouldn't that happen when f is increasing? So let's look at our picture, and we'll see when is f increasing. And it's increasing from -5 to -2, then it decreases, and then it starts increasing again from 0 to 3, and then it just kind of levels off and goes flat. Okay, so this is your answer, and you get 2 points. So to do, you have the answer, that's 1 point, and then your justification, which would be all, all this work that we showed. I mean, basically this is the main one. When is f prime greater than 0? Would be 1 more point. So part C was worth 2 points in total. Okay, so part D is asking for when does G have a critical point and classify it as either a max, min, or neither. So G will have a critical point when G prime equals 0. Okay, so what is G prime? Well, didn't we say earlier that G prime equals f of x? So I'm going to substitute f of x for G prime. And the question really is, when is f of x equal to 0? So you're going to look at your picture, and you're going to see that from the picture, the y value is 0 when x is -2, x equals 1. Okay, so if you look at x equals -2, there's no sign change. It never went through the axes. So at x equals -2, you would say there's no sign change. So neither a max or min. Now at x equals 1, it is going through, and so it was first negative, so negative, and then it went through and was positive, so that would be a min. So you would say went from negative to positive, so it's a min. Okay, so what were your point values for this? If you did this, that was worth 1 point. If you found these two, that was worth 1 point. And then your answers were worth 1 point, so that was worth 3 points. Okay, and that is number 3, and I'm only 30 seconds over.